Hello and welcome everyone. So as we are discussing about pre-stress concrete, and this type of PSC concrete is very efficient when we are going for the design of long span structures, especially in the case of bridges. So one thing that can come into the mind that when we are going for the design of longer span of structures, then the tendons length also have to be very large. But in reality, in market, the tendons come into the normal sizes. So what to do? So at that juncture, we have to make some kind of connection between two tendons just to achieve the continuity. Okay. अगर हिंदी में बोले तो दो टेंडन्स के बीच में गांठ नहीं लगाया जा सकता जैसे रस्सियों में लगाते हैं. So how to connect two tendons? That is done by the splicing of tendons. Okay, and they are called tendon splices. So basically there are four ways of splicing tendons. Okay, so here we are going to discuss first the that is known as screw connectors. Okay, and these screw connectors, as the name suggests, here we are using simple screwing technique, and for screwing we have to make threads. ठीक है, थ्रीड्स मीन्स चूड़ियाँ, जैसे आप नॉर्मल नट एंड बोल्ट्स में देखते हैं ना, थ्रीडिंग की होती है. सो थ्रीडिंग इज डन एट द एंड ऑफ हाई टेंसाइल बार्स, एंड टू थ्रीडेड हाई टेंसाइल बार्स आर brought together, just like you are seeing. The first one is here and another one is here, and both are threaded at the end. Okay, and this is here tighten into the coupler, and coupler is a metal sheath of enlarged diameter and sufficient length, also just used to cover the splice. Okay, but screw threaded connectors are not recommended for splicing heat treated pre-stressing steels. These are those pre-stressing steels which are given heat treatment, and because they are highly susceptible to stress corrosion. And one more loss that happens in screw connector is that we have to make threading, and threading involves removal of material from the bars. So cross sectional area is somewhere less, and because of that the strength of the bar also get reduced. Okay, and the next kind of tendon splice is torpedo splice, and it consists of basically triple bases. There are triple bases, they are arranged so that they can secure the wires passing through them. See, triple bases can allow the entry of the wires into them. Okay, like this, if these are the triple bases, and they will allow the entry of the wire, but they will not allow the wire to get out from their clutches. Okay, and these triple bases are securing the wires, and the entire unit is being covered and protected by a sleeve. So here we are seeing in this figure also the bases are shown. Okay, and these are triple bases. There are triangular type of shape, cross section shape in these bases, and this sleeve is basically covering and protecting the entire arrangement. And the other high tensile wire is also put into the triple bases, and both are connected with a helical spring here. Okay, what happens by the use of a spring here, that there is no reduction in the strength of the wire. First of all, the first advantage is the strength reduction is not there, because when you thread the wire, what happens that the cross sectional area is removed, and hence the strength will reduce because of reduction in cross sectional area. But in this case there is no reduction in the strength of wire, and also they are mostly used for splicing cold drawn wires, and which are adopted for circular pre-stressing of tanks, and they can very easily adjust themselves, because the spring is there. When there is a little more stretch or little more contraction, they can be easily sustained by this spring that is provided into the torpedo splice. So this is also additional advantage in this type of tendon splice. The third type of tendon splice is clamp splice. Now this splicing technique is using the metal clamps here, and clamp plates are shown here. Okay, you are seeing these are the clamp plates. Okay, and all these clamp plates are punched with a hole into them. Okay, and through these holes what happens, we pass through all the bolts. Okay, and bolts can be in the rows pattern or chain pattern like that, and there can be one bolt in a row or two bolt, three bolt, but this is cross sectional view of clamp splicing. And if this is the first row on one side and this is the second row on other side, so in a row there can be one bolt, two bolt, or n number of bolts, but in the cross section we will be seeing only one bolt. Okay, from the front. So this type of clamp splice are used to splice the high tensile wires in between them. And how they do this? By the method of arrangement in which these clamps are tightened with the bolts. Okay, and there are grooves also made into these clamp plates to pass the tendons through them. Okay, and you can see the tendon number 1, 2, 3, 4 are coming here, and they are going through this groove here, and up to this is the length of this clamp plate, and another tendon is coming from this side up to this length. So this is how connection between the series of tendons can be done here. And this is a little cheaper, and since they are equipped with simple instruments like nuts and bolts and series of clamp plates to housing the tendons, and due to punching and drilling, what happens, there is considerable reduction in tensile strength up to 50%. But this type of splice is efficient in a location where pre-stressing force has been sufficiently reduced, and we know pre-stressing forces can be less somewhere and can be more somewhere depending on the profile or the curvature of the tendon due to the friction. Okay, and the fourth and last type of tendon splicing method is the wrapped slicing. And as the name suggests, we are going to wrap one material over another material. So here we have two high tensile wires coming from each sides. One is here, another is here, and both high tensile wires are spliced by wrapping high tensile winding wires which are having a smaller diameter of 3 to 6 mm, and these small diameter wires are wrapped over these two high tensile wires. Okay, and this small diameter wires are provided by a wire serving machine, and that machine is pulling the wire like this, and wire is going, and the high tensile wires are rotating themselves, and slowly what happens, this is stretched from the or pulled apart from the wire serving machine, and this goes on wrapping the high tensile wire in the tendons. So this is how the wrapping wire are used. Generally 1 mm diameter is also used, and the maximum diameter of wrapping wire can be 6 mm. And the length of wrapped splice may vary from 200 to 300 mm, and a splice formed in this manner has a strength almost equal to that of the normal wire. Okay, and this type of splice is generally used for the wires of circular concrete tanks and anchorage loops. So since there is no punching, no drilling, or no threading is required, so the strength of the splice is similar to the high tensile wire itself. So this is all about the tendon splices, in which we splice the tendons to achieve continuity by 4 different methods. And the first one is the screw connectors, in which we make threads and connect them, and under a coupler both the high tensile wires are connected. Second one is the Torpedo splices, no need of threading. You just have to bring high tensile wire ends into triple wedges, and they are covered under a sleeve, okay, and they are connected with a helical spring to adjust the stretches, expansion or contractions very easily. And the third method of splicing is clamp splicing, in which we use clamp plates, nuts and bolts to splice the large number of tendons one time, okay, and in one go we can connect many tendons, but of course the strength is reduced here because of so many operations undergoing into this type of splicing. But of course it is good and much more efficient in case where there are pre-stressing forces are lesser. And the last method of splicing is wrapped splicing, and in which we just connect the two high tensile wires by wrapping them with a small diameter high tensile wires served from a wire serving machines, okay. So this is all about how we do tendon splicing. And now the next question that comes, how we do pre-stressing in pre-stress concrete. So there must be some systems, arrangements or mechanism through which we impart pre-stressing into the concrete and manufacture pre-stress concrete. So what are the different methods for pre-compression of concrete? So the first method is to generate the compressive forces between the structural element and its abutments using flat jacks, okay. And the development of hoop compression, especially when we are going for the design of radial elements in the case of cylindrically shaped structures like in the water tanks, and this is being done by circumferential wire winding. Also we go for the use of longitudinally tensioned steels, especially in the case of production of pre-tensioned PSC, okay, and here we tension the steel longitudinally and then we embed them in the concrete. And this method is also done in post tensioning, when we tension these steel bars longitudinally and then we house them into the ducts. So both the points are written here. We also use the principle of distortion. What we do distortion, especially in the statically indeterminate structures, either by displacement or rotation of a part related to the remainder, okay. And sometimes a limited amount of tension can be developed into the steel, and a limited amount of compression can be developed into the concrete by using expanding cements. So there are different types of pre-stressing systems ranging from flat jacks, circumferential wire winding, or using longitudinally tensioned steels, or distorting statically indeterminate structures, and by using expanding cements. Now expanding cements are those cements which have the property of expand with time, because there are reactions, and under those reactions of concrete, what happens, the volume of concrete slowly increases with time. So what happens into that, actually when the volume of concrete will increase, it will also stretch the wires embedded into them, okay. And the most widely used method for pre-stressing of a structural concrete element is longitudinal tensioning of steel bars. This is being done in the pre-tensioning also as well as in post-tensioning also. Longitudinal tensioning of a steel is very easy to understand. You take a steel tendon here and you just tension them longitudinally by applying a force P, okay. And you can then embed them into concrete if you are going to produce pre-tensioned PSC, or you may house them into the ducts if you are going for the production of post-tensioned PSC, okay. And for arches and pavements, pre-stressing is simply done by application of direct compressive forces between abutments. See, if our structure is having some arches like this, so pre-stressing can be done simply by applying direct compressive forces between abutments. Abutments are support here, okay, like these are the supports here, abutments are shown here, and this is the another abutment. So when we simply apply direct compressive forces, arches are under pre-stress. Okay. And for circular tanks and pipes, pre-compression is imparted by circular pre-stressing. Okay, this is also easier. And with the development of expansive cements, pre-stress in concrete can be developed by chemical pre-stressing. There are chemical reactions when we pour water on expanding cements, and they tend to increase their volume with time, and with increase in volume they stretch the steel bars, and the steel bars are under tension, and consequently the concrete in that zone comes into compression. So this is what the mechanism of pre-stressing, isn't it? So tensioning devices, if we see, basically they are categorized into four types of devices. Okay. So these are the four types of devices which are used for tensioning steel tendons. First one is the mechanical type, second one is the hydraulic type, third one is the electrical type, fourth one is the chemical type. Mechanical types, and I will be discussing a series of mechanical tensioning devices through which we tension these steel tendons. And there may be devices with or without lever transmissions, and there may be in the conjunction with the pulley blocks and different mechanism like that. Okay. And the next type of tensioning device is of hydraulic type, under which there comes also a series of devices which we will also be discussing very soon in the next video, and they use basically the hydraulic mechanism. You must have done or seen in somewhere or in some video how by simply hydraulic pressure we can lift a van, or you must have seen some crane mechanism which we designed with the help of simple syringes. Okay. Next type of tensioning device is electrical types or the thermal types, in which the steel wires are electrically heated and then they are anchored before placing concrete in the molds. Okay. And what happens when the electricity is passed through these wires, they become heated and they expand in their length, and then we pour concrete onto them or we anchor those heated steels. What happens when the electricity supply is stopped? Then what happens? They tends to cool down, and on cooling they want to be relaxed, but there is no chance of being relaxed. So what happens? They are in tension all the time. Okay. When someone is not relaxed, he is always in tension. So steel bars are also in tension, and when they are in tension, the concrete around them will be under compression to resist. Okay, so this is how pre-stressing is done by electrical type of tensioning devices. Next type of tensioning devices, as we have discussed repeatedly, is the chemical type, in which we use expanding cements, and the degree of expansion is controlled by varying the curing conditions. Okay, so basically if we categorize all these tensioning devices, there can be a few tensioning devices that comes under pre-tensioning devices. Okay, in which we tension the wire before concreting, and there can be few tensioning devices which will be post-tensioning devices, and post-tensioning devices are those devices which imparts tension to the tendon after concreting. Okay, so basically in the pre-tensioning devices we will be seeing mostly two devices, and in post-tensioning devices I will be discussing almost 6 to 9 devices. Okay, and this we will discuss into the next video. Okay, but here today we will discuss about the pre-tensioning devices, and as we have discussed about pre-tensioning, what happens here first of all we tension the tendons. Okay, the tendons are first tensioned between the rigid anchorage blocks. So you can see here the anchorage block here are shown. These are the anchorage blocks, and this is the jack, and jacks are installed against these abutments. Okay, and this is the casting bed basically, on which we cast the pre-tensioning pre-stress concrete. Okay, so here the tendons are first of all tensioned. First of all, we mount the steel tendons onto them, and through jacks we tighten them, and as we go on tightening, what happens, tendons are firstly tensioned. Okay, and then we do concreting, okay, onto the ground or in a column. So this is how we do in case of beam with straight tendon. And in this figure we are seeing the beam with straight tendon, okay, straight tendon, and the tendon is straight. Tendon is not having any profile, as we have discussed in the case of concordant type of pre-stressing. And here tendon is straight, but there is some eccentricity here. Okay, eccentricity is the distance of the axis from the centroidal axis. So this is centroidal axis, and the distance between this axis and the axis of tendon is the eccentricity, and this distance is represented by E. E is the eccentricity. But it is not necessary that all the time tendons are mounted in a straight fashion. Sometimes we also cast the beams with variable tendon eccentricity, and you can see in this diagram that almost similar kind of arrangement is shown here. But what happened on this type of casting bed, this is the casting bed, and on this we provide some support force here mechanism, which is almost imparting variable eccentricity to the tendon. Eccentricity is varying here, as you can see here. Here eccentricity is something E1, and eccentricity is very increasing E2, and here it becomes constant up to E3, and again it goes on reducing E2, E1, and eccentricity finally reduces almost to 0. So we can provide tendons either with constant eccentricity, okay, as shown in this diagram, okay, here the eccentricity is constant, or variable eccentricity as shown in this diagram. B, with tendon anchorage at one end and jack at other, okay. So in this type of pre-tensioning system, one end is the tendon anchorage and other end is the jack, okay. Remember these, tendon anchorage and jack is there. So with the forms in place, concrete is poured and casted around the stressed tendon. So this is how pre-tensioning system works. So as you are seeing in this figure, that by using this type of pre-tensioning system, we can manufacture only one pre-tensioned PSC element or block or slab at a time. But what to do when we have to manufacture a large number of pre-tensioned PSC blocks, or we need mass production? So that type of pre-tensioning system is also explained here, and that is known as Boyer's long line system of pre-tensioning, and in this we go for mass production, okay. As written here, long line process is used for mass productions, and here as you are seeing, the similar type of casting bed is shown here. As you are seeing here, the casting bed is shown from one end up to the other end, okay. And this casting bed has two abutments. One is used for tendon anchorage, anchoring the tendons, okay, and other end is basically installed with the jacks, okay, tendon jacks here. So tendons are again here stretched between two bulkheads several hundred meters apart, because now we are going to produce in a mass number, okay, and a number of similar units are casted in between, and tension is applied by hydraulic jacks or movable stressing machines, and the wire or strands when tensioned are attached to the abutments by steel bases. So after the tendons are stretched, then we cast the beams by pouring concrete, and after the hardening of concrete, then in this diagram as you are seeing, beam 1, beam 2 and beam 3, when the concrete gets hardened, what we do, we simply cut these bars from the end here and remove these beams from the casting bed, and these are the beam 1, beam 2 and beam 3 after concrete has hardened, and in this the tendon is here stretched. So this stretched tendon will compress the concrete in the bottom zone, and that's how we produce pre-tensioned pre-stressed concrete. And all these manufactured beams can be transported to the site for use. Just like in the railway lines, there are different sleepers that you see, and all those sleepers, how they are produced, how all those sleepers have got so much strength that they can bear the trains moving on them day and night, 24 into 7 into 365. How can they do it? Such a big amount of load that is coming through the metallic wheels of the trains moving on them, just only because of pre-stressing. And pre-stressing is done in all those sleepers into the industries, and from the industries these sleepers are transported to the site or the railway lines where they are being used, and they are used to make the railway lines, or somewhere these pre-tension PSC are used for constructing structures also. So this is how we impart pre-stressing to tendons by using these two simple methods of pre-tensioning systems, and we shall meet in the next video where we will be discussing a number of post-tensioning systems also. So till that, stay tuned and stay safe. Thank you.